Hello, I'm Commander Chris Kreitlein, U.S. Navy retired. I'm a navigation instructor with Globus Horizon. I also am an adjunct professor of navigation at Pensacola State College, where I teach a class in celestial navigation. While teaching this class, it's come to my attention that many of my students don't have one of the basic skills that one would expect from a maritime navigator, and that is the ability to plot and maintain a dead reckoning track and position on a chart, and how to use a universal plotting sheet. So that's what this video is going to cover. The essential elements of a universal plotting sheet and how you can use it to plot and maintain a dead reckoning track and a dead reckoning position. So sit back and let's dig into it. Hope you enjoy it. Okay, we're going to learn through this video how to plot a DR position using a universal plotting sheet. Once again, I'm Commander Chris Kreitlein with Globus Horizon, and I'm the author of this book, Simple Celestial: Navigation by the Heavens Made Easy. You may have seen my other videos on YouTube describing how to shoot the sun at local apparent noon. I encourage you to watch those videos if you'd like. And then, of course, order this book if you'd like to learn celestial navigation. Okay, let's continue. Now, some terms. We're going to talk about what plot and plotting means, what a DR track and DR position are, as well as what a universal plotting sheet is and how we use it. First of all, plotting is marking navigational information on a chart or universal plotting sheet that I'll call a UPS. That includes positions, tracks, points, intercepts, set drift, whatever navigational information that helps you get to where you want to go that you want to write down on a chart. Writing it down with a pencil, a parallel ruler, using dividers, all the tools, that is called plotting. Now, there are some other terms we want to cover before we move on. Course. Course is a direction of intended movement of your boat, starting out at 000, or what I generally call 360, on around the compass clock, all the way through 090, 270, all the way around to 360 again. This is the course where we're wanting to go, and it may be entirely different than the boat's heading. That all depends on the wind, the set, the drift, where you have to point your boat in order to make the course you want. Speed we express in knots. A knot is nautical miles in 1 hour of intended movement. Knot is not nautical miles. All right, nautical miles is a specific measurement of distance. A knot is speed through the water. How many nautical miles you're making in 1 hour, that is a knot. Be it 3 knots, 4.5 knots, 7 knots. 7 knots, of course, means in 1 hour you go 7 nautical miles. Time we express on a 24-hour clock. 0300, 1200, all the way to 2400, and then we start over again. Heading is the compass pointing angle of your yacht's bow. Where are you actually pointing? Don't confuse that with course. You may have to take a slightly different heading to make a course good over the water. Now, getting back to those other terms. DR, what does DR mean? Well, a long time ago, the best I understand it, it was originally deduced reasoning that altered over the years to become deduced reckoning, finally dead reckoning, and then today we call it dead reckoning. It's just a perversion of that original expression, deduced reasoning, and what it means is the best guess of where we're at or where we're going based upon the navigator's skillful reasoning on where he intends to go or where he believes he is. It's not a certain knowledge. It's the navigator's skillful reasoning, taking into account all he knows and all his experience to determine where he thinks he is and where he intends to go. Dead reckoning. Now you can have a dead reckoning track, a DR track. This is a course plotted from a position, a course you intend to follow plotted from a position. Well, that naturally raises the question, what is a position? It's not that simple. There are essentially three different kinds of positions. One is where you assume you are. A second one is where you think you are. And then finally, the best position is where you know you are. All these three are different. The first one, an assumed position, is an expression we use in celestial navigation. All right, we won't discuss that today. That's for a different lecture on celestial navigation. We do, of course, today concern ourselves with a DR position. What is a DR position? Well, it's where we use our navigational skills to come up with the best guess estimate of where we are. And here I have two examples. This first one is a circle with a pencil dot in the middle, and we always label it with the time. This is a position we put on the chart or on the universal plotting sheet of where we think we are. Always labeling it. Now this second one down here is on a DR track. Here is a course that we're trying to follow. We don't know for certain where we are on this course, but we think at 12:03 we are either here or we are going to be here. Okay, this can be where you're going to be or where you are. You know, our best guess estimate. At 12:03 we either are here or we should be here. Okay, the last one, of course, is a fixed position or a position fix. Now, this differs in that this is for certain where we are at. And it comes from some source such as radar, GPS, celestial navigation. We can triangulate on land objects or triangulate on sea objects, or if we know where a buoy is and we're right next to a buoy, well, that's obviously where we're at. We don't really have to guess too much about it. If we're right next to an oil rig, then we know exactly where the oil rig is. Well, that's where we are. So these are actual fixes, and they are depicted on the chart or UPS in this fashion with a hash cross in the middle of it. Once again, labeled. At 0230, we are definitely here. This is not a guess. This is where we're at. Here's another one. You can draw it either way. At 2359, we are here. So this is a position fix. I hope you note the difference between a DR position and a position fix. All right, now, a DR track. Well, a DR track is where we lay out or plot a desired magnetic compass course along with a speed. Now, some people might use true, but I always use magnetic because that's what I'm looking at from the helm, is my magnetic compass. I have my GPS set to magnetic. So that's what I always use, and that's what I recommend people use. However, if you want to use true, be my guest. So, a DR track starts from a position. In this case, we're using a fix. We could have used a DR position, but here we're using a fix, 2359. We lay out a line, a course of 100, labeling it with our speed of 5. Now, we don't know where we are on this line. This is an intended track, or this is where we think we're going, somewhere on this line. This is a DR track, not a DR position. We haven't gotten to a position yet. This is our track. This is how you label it. A C for 100 and an S for speed for 5 knots. We're going to be traveling along this desired magnetic course. A DR track. Now we have a DR position. A DR position differs from a track in that it is a position which is a combination of course and speed times time. All right, there's nothing certain about this. This is where we think we are or where we project we're going to be, based simply on our course and speed over time. In this case, a course of 100, a speed of 5 knots for a time of 1 hour. All right, so we measure off, of course, in 1 hour at 5 knots, that's 5 nautical miles. We lay out, we plot out 5 nautical miles, and we draw this little loop. There will generally be a pencil mark right here in the middle, and we label it. If we left at 23:59 and we're gone for an hour, that brings us to 00:59. This is where we intend to be, or where we think we are, after 1 hour. Then we can extend the course line beyond that, provided we don't change course right here. So this is a DR position. This is our best guess based upon our course, speed, and time of where we think we are. These are the only three factors that have gone into this DR position. Nothing certain about it. This is our best guess estimate based upon our navigational skill of either where we're going to be at 0059 or where we are at 0059. A DR position. Now, let's practice plotting a track and a DR position. This position fix, I'm going to give it to you at 1400. We're going to be on course of 181, speed of 8 knots for a time of 2 hours and 30 minutes. All right, let's plot the track and position and properly label it. Here is our position. I'm giving it to you at 1400. We're going to lay out our track, our course of 181, our speed of 8 knots. Then we measure out the distance and we draw our little loop for a DR position, where we're going to be or where we are at that time. And remember we said it was 2 hours and 30 minutes. So when we laid out this track, all right, it's course and speed times time. We're going to take our course and speed for 2 hours and 30 minutes. Well, at 8 knots, how far will you go in 2 hours and 30 minutes? Well, 2 hours times 8 knots is 16 nautical miles, plus another 30 minutes would be half of 8 miles, would be 4. You add that together, and that gives us 20 nautical miles, and we'll be there at 1630. This is our best guess estimate of where we'll be at 1630. This, of course, is 20 nautical miles laid out on this course line. Okay, please review this. Stop and review all this to make sure you understand how to lay out a DR track and a DR position before you go further with this presentation. Review and make sure you understand it. Okay, assuming you've done all that, let's continue. Once again, 2 hours and 30 minutes is expressed on this line by the 20 nautical miles. And our time is down here at 1630, always labeling it. Now, here we have a universal plotting sheet. Well, why? You can do all this work on your chart, but charts nowadays are $20, $22 each. These universal plotting sheets are very cheap, so it's smarter to do all your math, all your plotting on these sheets and then transfer the final position onto your chart. That's my advice. That's what I like to do, so I don't scribble and erase all over my expensive chart. You can get a pack of 50 of these for like $5 or something. So it's better to scribble on these and then transfer the result, okay, onto a chart. Plus, there's a little tool here that's necessary that we'll talk about on this universal plotting sheet. Okay, now let's take a closer look. We have this ring in the middle. This is called a compass rose, and it's just like your compass. It starts out at 000 or 360 and goes all the way around to 360 again. We're going to use this compass rose to lay out courses. All right? So, what we can do then is take our parallel rulers and measure off a course of 060. Then we can move this parallel ruler anywhere on this universal plotting sheet we want to and lay out that course of 060. Once we have a DR position or a fix, we just measure this off, slide the parallel rulers over, and lay out our course. Of course, I mean, this could be 270, 180, any degree on the compass you want to use. Depending on what course you want, you can transfer it over to a position. For example, here I've given you a position right here. Now we're going to lay out that course of 060 from this position fix. See this little X? This means it's a position fix. It's not a DR position, it's an actual fix. All right, let's take our parallel rulers, spread them out, draw in our course line, and there we have it. There's our course of 060 from that position fix. I'll show you in a few minutes how to plot a position fix on the UPS, but right now we're just talking about how to transfer a course off of this compass rose. So once again, review this closely. Make sure you understand how to transfer a bearing line for a course off of the compass rose and transfer it anywhere on the UPS to your position. Of course, we want to label it 060. Now, a couple interesting things about this UPS. You'll notice we have some lines on here. These lines that are parallel, going right to left or east to west, are parallels of latitude. We can see 3 right here. There's another one down at the bottom. So there are 4 parallels of latitude on a UPS. However, there's only 1 meridian of longitude on here. That's interesting. We sometimes need to draw more, and I'm going to show you how to do that in a few minutes. All right, so we can label the latitudes. I'm in Pensacola, so I'm going to use Pensacola latitude and longitudes. Put 30 in the middle. 30 degrees north latitude is where we're at in Pensacola. Label this other one 31 because these are 1 degree apart. These are 1 degree of latitude apart, okay? Then we can put 080 west longitude right here in the middle. So we're making progress in labeling up this UPS and getting it ready to use. You'll notice here in the middle, right here in the middle, it starts here and goes up to 10, then to 20, to 30, 40, 50. This is for laying out positions. These are minutes of latitude. Minutes of latitude. Of course, there are 60 minutes of latitude in 1 degree of latitude. So we can use these to lay out positions. We also, and this is critical, we also use this. Now we know, or you should know, if not, take my course on celestial navigation and you'll learn that degrees of latitude are 60 nautical miles apart. So each one of these corresponds to 1 nautical mile. This whole spread here is 60 nautical miles. So we can use this to measure anywhere on this UPS. Okay? This is what we use to measure distances. All right, so we can use these then to lay out positions. Here's 30 degrees, 20 minutes. Here is 30 degrees, 50 minutes. I hope you get the idea here. On up, we could do 3110, 3120, all the way up to 32 degrees north latitude. But look over here. There's nothing here for longitude. You know, there's no hash marks. How do we lay out other longitudes on this universal plotting sheet? How do we lay out longitude meridians on here? Well, there's a little aid down here that we're going to use. This little aid is a longitude plotting aid. This is for plotting longitudes. All right, don't use this for measuring distance. Only this scale in the middle here is for measuring distance. This is for laying out longitude only. Why is this necessary? Well, you may or may not know that latitudes are parallel, running east and west around the Earth. They're all parallel, and every degree is 60 nautical miles apart. But look at longitudes. Here's 0 degrees longitude, here's 45 degrees west longitude. Are these parallel? Of course not. At the equator, a degree of longitude is about 60 nautical miles. But they come together at the North and South Pole. So this distance between them is constantly getting smaller as you go north from the equator or as you go south from the equator. So it's not a simple matter of drawing a straight line, 60 nautical miles apart like we can with latitudes, because these things converge at the pole. So we have to use this little aid down here. Now right down here, or look on this side here, you see it starts out at 0, 10, 20, 30, 40, 50. This corresponds to your latitude, either north or south. And this is how far apart longitude lines are at that latitude. Please get this concept in your head. This represents how far apart longitude lines are at specific latitudes. Here's the equator, this heavy line here. At the equator, longitude lines are this far apart. Now here's 50 over here and here's 0 here. So the other 10 to make 60 are right here. They're subdivided into 2 nautical miles, 2 minutes. These are minutes. I made a mistake. I don't want to mislead you. These are not nautical miles. These are nautical miles as well as minutes of latitude. But these are not nautical miles. These are simply minutes of longitude. So starting at this point, we go all the way and we have 60. 50 and then 2, 4, 6, 8, 10 to make 60. So this is 60 minutes of longitude at the equator. But you get up here to 60 degrees north latitude, let's say, and look how much shorter it is. Why? Because these meridians of longitude are converging at the North Pole. So they're much closer up here than they are down here. That's why you can't use this to measure. This is only for laying out longitude. So what do we do? How do we use this? Well, let's take a closer look at it. The first thing we do, remember, we're here in Pensacola, we're at 30 degrees north latitude. So we're going to draw a heavy line at 30 degrees because all of our minutes of longitude are going to be measured here along this 30 degree line. All right, this is how far longitude meridians are at 30 degrees north, or for that matter 30 degrees south latitude, but we're talking north here. So what I can do, I can take my dividers, I can measure this span of 60 minutes of longitude or 1 degree of longitude, and then I can transfer it right up here on a latitude parallel. I can transfer it up there, and then I can draw in a vertical line. This is our new longitude line. Now this is 80. We're in the west, so this is going to be what? 79. This is going to be 79 degrees west longitude. All right? If we were at the equator, this 79 would be over here somewhere, way to the right. Or if we were at the North Pole, it'd be right here, co-located with this 80 longitude line. But we happen to be at 30, so this is how far apart they are right here. So we can put one here. We can also put one over here on the left side of the UPS, and that would be 81 degrees west longitude. Okay, I hope you understand this. Once again, go over this again. Make sure you understand how we measure the longitude degrees right here. This is 1 degree of longitude, and then we transfer it up here in order to plot our additional longitude lines. See how handy that little tool is for us? Now, once again, let me caution you. Don't use this to measure with. This is only for laying out longitudes. All distance measuring has to be done off the middle here. Now here is one completely laid out. We're at north 30. We've laid out 2 longitude lines. We've labeled them 79, 80, 81. We've got 29, 30, 31. We're ready to plot. If you don't understand this, go back and review it. Don't go on until you have a firm grip on how we laid this out. All right, now we're ready to plot. Let's plot a fix at north 3030, west 8030 at 1500. This is where we are. This is a position fix. North 30 degrees, 30 minutes of latitude. West 80 degrees, 30 minutes of longitude at 1500. We're going to lay out a track, a DR track, beginning at this fix on a course of 025 for 6 knots, and we're going to go for 5 hours. Then we're going to change course to 095 and travel at 3 knots. You notice there's no time, so we're just going to lay this out as a DR track. Okay, let's go. All right, now first thing to do is to plot our fix. Now I said it was north 3030. Well, that's easy. Here's the 30 line, and there's the 30 minutes. So we just come over here and make a little pencil mark. North 30 and 30 minutes. So this is north 3030. The west is a little trickier. We said it was 8030. So, well, we know it's halfway between here and here, right? Because this is 60. 60 minutes of longitude. But we got to come down here and use our little tool. We put our divider point here, and then we span the gap to 30 minutes of longitude. We then take that span up here and spread it out and make our point right here. So this is our position at 1500. North 3030, west 8030. Here's 80, and our 30 we got right down here. This line is at 30, so we measure off 30 minutes of longitude and we transfer it right here. And this is where it puts us. Now we're ready to plot our DR track. We said it was 025, our course. So we put our ruler in the middle on 025, and then we transfer it over here and we draw our line. So this is a course of 025. Now we label it 025, speed 6 knots, and we're going to go for 5 hours. Well, at 6 nautical miles in 1 hour, how far will we go in 5? Well, that's pretty simple, isn't it? 30. So we want to lay out 30 nautical miles on this DR track. Where are we going to get it? Well, we're going to get it right here in the middle. Remember I said this is 60 nautical miles. We want 30. So we go up here 10, 20, 30. We measure 30 and we transfer it right up here on this DR track. We take our dividers, mark off 30, and then we move it right up here. We erase the rest of our line and we draw our little loop for our DR position. This is our DR position. Remember, we want to label it with the time. This was 5 hours later. So at 2000 we will be here. This is where we will be. This is our DR position. Well, we hope we're going to be there anyway. We intend on being there. But now remember, it said we're going to change course to 095 at 3 knots. So we got to transfer a new course up there. We lay out our parallel rulers here on 095 and we move it up just like we did before and lay out our new course of 095. Speed 3 knots, so we want to label it properly. Now, this is our new course. Our captain has not told us how long we're going to be on this course, so we cannot come up with a new DR position yet. We'll have to wait till he tells us. All we know is we're going to change course to 095 at speed 3 knots. Okay, we've laid out this track. Put in our DR position and laid out a new DR track. Once again, if you're uncertain about anything we've done here, review it again and again until you understand it. It's critical. This is an essential skill for maritime navigation. So what have we done? Well, we've explained the DR track, the DR position, what they are, how we use them. We've labeled a universal plotting sheet with our latitude, longitude lines. We've plotted a fix, our DR track, our DR position, and we've properly labeled everything. So that concludes this video on laying out a DR track and DR position. I hope you enjoyed it. I hope you learned something. You might want to watch the sun at local apparent noon videos that I have on YouTube. Teach you a little bit about celestial navigation. Then you might consider getting my book, Simple Celestial Navigation by the Heavens Made Easy. And you can order that book at globazon.com off the internet. Free shipping in the USA. My email, if you have any questions or comments on this video, feel free. If you've got questions, something you didn't understand, something I could elucidate more clearly, let me know. Send me an email at sales@globazon.com and I will respond. Okay, so I hope you enjoyed this. This is really kind of a precursor for going in to the sun at local apparent noon videos on celestial navigation. Once again, any questions? Send me an email.